Okay, problem number 31. We're asked to find the limit of the trigonometric function. So in 31, it's secant of 2 times x. So with any one of the other functions aside from sine and cosine, you know that you can put them all in terms of sine and cosine. So really, you only have to know very well the values that sine and cosine can have, and for the most part, that's only for also for like reference angles. And reference angles are 0, 30 degrees, 45 degrees, 60, and 90 degrees. And for the most part, most trig questions are only questions pertaining to one of those angles, unless that you're asked to evaluate them on like a calculator. So in this case, you're asked to evaluate it for x as it goes to 0, and 2 times x also just goes to 0. And the question becomes, is secant defined for x equal to 0? Because we know that the limit exists for all trig functions in their domain, so the question becomes whether or not 0 is in the domain of secant. So secant is, remember, I usually draw out sine, cosine, tangent, cotangent, secant, cosecant, and then a little arrow between the outer one, between sine and cosecant, between cosine and secant, and tangent and cotangent, because each one of these are reciprocals of one another. So secant is the reciprocal of cosine. So that means that if you want to evaluate secant of x, you can just evaluate whatever the reciprocal of cosine of x is. So the secant of 2x is 1 over cosine of 2x. Now, as x goes to 0, 2 times x goes to 0, so therefore cosine of 0 is 1. So secant is 1 over 1, which is definitely in the domain of secant of x, or secant of 2x. So therefore you can just use direct substitution on this problem, and secant of 0 is just 1. So for number 43, we did this one in class. We have a function g of x equal to x cubed minus x over x minus 1, and it says use the graph to determine the limit visually if it exists, and write a simpler function that agrees with the function at all but one point. So we'll do the all but one point first. We can factor out an x from the numerator. We have x cubed minus x. We can factor an x out from both terms. We're left with x squared minus 1. This is the difference of perfect squares, because we can write 1 as 1 squared. So therefore, this is the same as x plus 1 times x minus 1. So here we have a common factor in the numerator of x minus 1, which cancels out with the factor of x minus 1 in the denominator, and we get x times x plus 1. And this is a function in a different form, which also includes x equal to 1 in its domain. So if we were to just find a limit, so part A says the limit as x goes to 0 of g of x. Limit as x goes to 1 of g of x. As we approach 1 on the left and 1 on the right, we're both approaching the same value, and in the book that is 2. This agrees with our function in the other form, right? So if we were to put in 1 directly substituted into this function, we get 1 times the quantity of 1 plus 1, which is 1 times 2, which is 2. So that agrees. And with part B, as x approaches negative 1, approaching from the left and approaching from the right, it looks like we are going to 0. And that agrees here, right? So if I put in negative 1 into the first form, right, and we don't even necessarily need to use the other form, but we could, and you come up with the same answer. We get negative 1 minus 1, so we get negative 2 on the bottom. Negative 1 cubed, which is negative 1, minus negative 1, which becomes plus 1. So therefore we would get 0 in the numerator, which would drive the whole thing down to 0. So for part A, it's 2, and for part B, it is 0. Verified both visually and analytically. Graphically and analytically. For number 57, and this will be the last one that we do in this video. Let's see. Looks like that'll be the last one. We'll do the others in the next couple.